The lesson outcome for this video is, I can factor quadratic expressions when a equals 1. So the first thing I want to talk about quick here is, what is a quadratic expression? Well, as you can see here, we have an expression, and we've just been talking recently in class about information about this expression. First of all, we know there are 3 terms, and we know that the degree of this polynomial is 2 because the highest exponent on a variable is 2. So if this is a degree 2 polynomial, it is called a quadratic. All right, so that's how we know this is quadratic, because we have an x squared. The other thing I want to talk about really quick is when a equals 1 is the only type of factoring we're going to be doing in this unit, and a is obviously this value right here, and that is always going to be a 1. And if you think about how if it was a 1 written right here, 1x squared, you probably remember that typically we don't have to write the 1 right there. So if I were to erase that, I can't actually, sorry. So if I were to erase that, it wouldn't be there because we don't have to write it in. We would just have an x squared at the beginning of our polynomial. All right? And so things in this form right here are quadratic expressions when a equals 1. More on that on the next screen. But before we do that, we're going to talk below here about how, also in the previous unit, we took a binomial times a binomial and we would multiply it out and find out what we would get. Well, we're going to do that right now. The first way I'm going to do it is using the FOIL method, and you should remember that from, again, our previous unit. First, outside, inside, last. So we need to multiply the first terms. That's x times x, and that gives us x squared. Then we need to multiply our outside terms, which is x times 7. So that's 7x. We're going to write plus 7x. Plus I, the inside terms, that's 4 times x, so 4x, so plus 4x. And then last, the L stands for last, and that's 4 times 7, which is 28. So once we got to this point, you probably remember that we would combine our like terms. We have an x squared term, there's no other x squared term. We have an x term, and there's another x term right here. So 7x's plus 4x's would be able to be simplified. So we have x squared plus 7 plus 4 is 11, so 11x plus 28. Now what you should probably notice here is that this, right now, what we just got, is a quadratic expression. It looks just like this right here. We've got our leading coefficient is a 1 because there's no number right there, because 1x times 1x is 1x squared. We didn't have to write that. And then we have a number here in front of x, and then we have a constant over here. So here's a quadratic expression we arrived at after foiling this problem. The same thing could have been done over here in our other method, the array. Okay, and again, doesn't matter which of these you use. And if we take the x and the 4 here, and then the x and the 7 here, and we multiply, x times x gives me x squared. And then x times 7 gives me 7x. 4 times x gives me 4x. And 4 times 7 gives me 28. Again, we have like terms, 4x and 7x, that can be combined. And so we end up with, again, x squared plus 11x plus 28. The same quadratic expression, trinomial, here, because it was the same multiplication problem. So if you think about how we arrived at this quadratic expression by multiplying two binomial factors, if we, again, remember, factors are when we multiply things together. So this is a factor times a factor. And when we multiply these two factors together, we got this. Well, factoring a quadratic expression is finding these two things that we multiplied together to get this in the first place. So you can kind of think of factoring quadratic expressions as undoing FOIL, or undoing the array, and finding out what factors multiplied together to give us this. Let's try some on the next screen. So this might look familiar. I used the exact same expression quadratic expression. It's a trinomial. And I'm going to show you the process of trying to take a quadratic expression and find out what are the two sets of parentheses going to be that would multiply together to get me this. Okay? So here's what we want to do. Here's our steps. We're going to start by, now if you remember from the previous screen, we had ax squared plus bx plus c, right? So c is this term out here. The first thing we're going to do is we're going to write that c term, the last term, the constant term, over here in this box. Now remember, if it's positive, make sure it's positive, which it is. If this was a negative, make sure you write in a negative. Now what we're going to do is we are going to list all of the factors of 28. So this is exactly what we've been practicing in our previous unit. 1 times 28, and 2 times 14, and 4 times 7 are the factors of 28. Our next step is to add our factor pairs. Okay, so I'm going to add, again, remember we got these by multiplying, so 28 is 1 times 28. Now I'm going to add them. Okay, what's 1 plus 28? Well, it's 29. What's 2 plus 14? Well, that's 16. And what's 4 plus 7? That's 11. What we need to do to find the factors that go into these parentheses so that if I multiply them I get to this, we need to find the factor pair that adds up to this middle b term right here. Okay, so which of these numbers here match this middle term of 11? Well, obviously this 11 right here, and therefore 4 and 7 are the numbers we need to put into our parentheses to list our factors. Okay, so what we're going to do is we're going to say, if I were going to FOIL this out, first, outside, inside, last, and arrive at this, what would I have to multiply here and here to get to x squared? Well, it's x times x. X times x will get us that x squared. Now, we're going to take the two terms right here that we found out they multiplied and gave me 28, this number, and they added to give me 11, which is this number. So we have to multiply to get this number and add to get this number, which are 4 and 7. So now we're going to put in plus 4 because 4 is positive, and plus 7 because the 7 is positive. We now have the factors that we started with on the previous screen. If, again, we FOIL it, we'd get x squared plus 7x plus 4x plus 28, right? X squared plus 7x plus 4x plus 28. Then we would combine the 7x and the 4x, which is 11x, and you'll notice that that is our quadratic expression right there. So our answer is x plus 4 times x plus 7. We have factored the quadratic expression. And just to make sure that you guys see earlier when I said we have to find the two values that when we multiply them we get this and add them we get this, notice that's exactly what we did right here by using these two numbers. You see the 28 is right here. 4 times 7 is 28. And then 7 plus 4, 7x's plus 4x's is 11x, which is why they add up to the middle term and they multiply to give me this term. Okay, so we're always looking for these two numbers that add up to this and multiply to give us this. And those terms are going to go in the parentheses. Okay, let's try a second example. We still have our a value as the 1 in front of the x squared. Our b value is this number right here in front of x. And our c value is this number right here off to the right, our constant. We always start by writing that c value into this rectangle here, and it is positive 14. Now we're going to list all of our factor pairs for 14, 1 times 14, and 2 times 7, and there are no other factors that give us 14. Now we're going to add these. So 1 plus 14 is 15, and 2 plus 7 is 9. Now, 15 and 9 are the two sums we have, and we're looking for which of these matches our B term right here. Well, the answer is right now neither of them do. We need to have negative 9, but we do have positive 9. And so if we have positive 9 and we need negative 9, we need to just do a quick switch with these two numbers right here, 2 and 7, so that we get a negative 9 instead of a positive 9. Now this will work because if we need a negative 9, we actually would need both the 2 and the 7 to be negative, because negative 2 plus negative 7 is negative 9. And the thing is if we change both of these to negative, it's okay, because what's a negative times a negative? Well, it's positive. So we still get positive 14 right here with a negative 2 times a negative 7. We still get positive 14, yet when we add them, we get the negative 9 that we needed. So now we have our factors, negative 2 and negative 7, that we need in our parentheses. So we're going to go back over here and write our two sets of parentheses. We know that x times x is going to give us the x squared we need here, and the negative 2 and the negative 7 are going to get us the positive, positive 14 that we need here, but when we add them, we get the negative 9 in the middle. So here are our two binomial factors that when we multiply them together, we get our original trinomial. And we will, of course, practice a lot of this factoring in class, so when if you have questions, go ahead and ask.